All right, so today we're going to do section 1.4 on segments. I promise this video is going to be short and sweet. So first we're going to talk about the segment addition postulate. And so the segment addition postulate is exactly what it sounds like. I am going to read you this complicated definition, but I'll explain it in easier terms. So it says, given 2 points A and C, a third point B lies on the line segment AC if and only if AB plus BC equals AC. So the segment addition postulate is just this. It says given 2 points A and C. So here's my segment, my 2 points A and C. B lies on the line segment. It doesn't say it's in the middle, it just says it's on the line segment somewhere. If and only if AB plus BC equals AC. So it's just telling you these two parts added together equal the whole thing. That's it. Okay, there are 2 examples here, but I am only going to do one of them because they are exactly the same. So here goes. I told you the other day to always draw a picture if there's not one. So I am going to start with a picture. If C is between D and E. So I'm going to stop right there and I'm going to draw a picture of that. Here is D and E, and it says C is between D and E. We know that DC is 1/2 times 4x plus 6. I'm going to go ahead and distribute that 1/2 just so I can get rid of my fraction. 1/2 times 4x is 2x. 1/2 times 6 is 3. So DC is 2x plus 3. And we know that CE is 3x plus 1. And we know that DE, the whole thing, is 44. So I'm going to tell you each part, and then you have to figure out how to write the equation. I think that's the simple part, though, because I've given you 2 parts, and I'm giving you the whole thing. So the 2 parts add together to make the whole segment. So there's your equation. 2x plus 3 plus 3x plus 1 equals 44. Part plus part equals whole. All right, so now we just have a simple algebraic equation to solve. I'm going to combine like terms. 5x, 3 and 1 gives me plus 4 equals 44. Can subtract the 4 over, so 5x equals 40. Divide by 5, so x equals 8. Again, make sure you're answering the problem, though. It says to find DC and CE. So I am going to go back and plug that in. If DC is 2x plus 3, that's 2 times 8 plus 3. DC is 16 plus 3, so DC is 19. Then I'm going to come over here and plug in 8 as well. 3 times 8 plus 1, so that's 24 plus 1, so CE is 25. Again, I can do some quick math to see that I'm right. 19 plus 25 will give me 44, whole thing. Okay. I am going to skip example 2 because it's just like example 1. All right, let's move on to segment bisector. So you can see that my cutting skills are no good. Maybe I need to go back to kindergarten, something. So here's the definition of a segment bisector. So segment bisector is a line, ray, or segment that divides a line segment into 2 equal parts. Okay, so here's my line segment. We'll call it AB just for fun. And a segment bisector is either a line, a ray, or a segment that divides it. So let's make it, how about a ray? Here's a ray. We'll call this ray XY. And it cuts it into 2 equal parts. Remember, I told you the other day, if something is cut into 2 equal parts, it has to be known. You have to tell me. And so remember, those marks mean that those 2 things are the same measure. Okay, so let's look at our example for segment bisector. So we're going to look at example number 3. EF bisects AD at C. So I'm going to start by drawing that. EF is doing the bisecting of line segment AD. So I know that line segment AD will be easier for my picture if I draw it this way. So there's AD. EF is bisecting it. So there is EF. If it bisects something, remember it cuts it in half. So I am going to go ahead and mark that these two parts are congruent because it's been bisected. And it says it bisects it at C. So I'm going to label this point right here where the bisecting happens, C. All right, now I'm going to keep reading to label my picture. It says if AC is 5x minus 8 and CD is 16 minus 3x. Okay, so again, you know you're writing an equation. You just have to decide what your equation is going to look like. Do they have to add up to be a specific number? Do they have to add up to be 90, 180? Or are they equal to each other? And so remember, these lines mean that they equal each other. So that's my equation. 5x minus 8 is equal to 16 minus 3x. They have to be equal because it's been bisected. Okay, I'm going to start by moving my 3x over to the left-hand side. So I'm going to add 3x. So we've got 8x minus 8 equals 16. Can add 8 on both sides. 8x equals 24. And I can divide by 8 on both sides, so x is 3. Let's go back and check out our problem. It says find the value of x, so we've done that, and find AD. Okay, well that's a little different because I don't know how far it is from A to D. I don't know that whole thing. But here's what I do know. I know this distance is 5x minus 8. This distance, excuse me, is 16 minus 3x. So I am going to stop for a second. I can plug that 3 in. So 5 times 3 gives me 15. Minus 8 is 7. So this distance right here is 7. So we can think logically about this. If the distance from A to C is 7, then that must mean the distance from C to D is also 7. We can double check that if you want to. 16 minus 3x. So if I plug in 3 for my x, 3 times 3 is 9. Well, 16 minus 9 gives me 7. So I'm right. And that must mean if each part is 7 from A to D, must be 14. Okay? Like I said, I'm going to skip example 4. It's just like example 3. And let's jump down to our last term for today. Midpoint of a segment. My cutting skills are still bad. So midpoint of a segment. It says a point on a line segment that divides it into two equal segments. The halfway point of a line segment. Goodness gracious, y'all. Okay, so my picture for that is going to look something like this. It's a line segment, it says. So we'll call it AC. And it's the point on the line segment that divides it into two equal segments. Remember, that is not an acceptable picture. You've got to have these marks letting me know that they're the same. Two equal segments. All right, so let's work one of those examples and then I'll be done. All right, let's do this first one since it's got a fraction just to mix things up a little bit. So again, as always, I'm going to start by drawing my picture. So the picture of this one, it says M is the midpoint of PQ. So here's line segment PQ. M is the midpoint. So I'm going to mark that those are the same because M is in the middle. We know that PM is 1/2 times 10x plus 16. I am going to go ahead and distribute my 1/2. Remember, when you distribute, you multiply. So 1/2 times 10x is 5x. 1/2 times 16 is 8. So from P to M is 5x plus 8. And the other thing I know is PQ is 76. So that's the whole thing. Okay, so you might be thinking, well, wait a second. Those two things aren't equal. 5x plus 8 isn't equal to 76. I don't have enough information. How am I going to figure out what x is? And so here's what I do know. Here's what I want you to think. If I don't think I have enough information, well, first of all, you do, but you've got to figure out where it's coming from. So we know, we marked on our picture that PM is congruent to MQ. So if from P to M is 5x plus 8, Doesn't that mean that from M to Q is also 5x plus 8? Don't they have to be the same? And so now this problem should remind you of the segment addition postulate. Got two parts. They equal the whole thing. Okay, so here goes. Here's how I'm going to work this one. I'm going to do 5x plus 8 plus 5x plus 8. The two parts added together have to equal the whole thing. All right, so I'm going to start by combining like terms as always. 5x and 5x is 10x. 8 and 8 is 16. Equals 76. I can subtract 16 on both sides. So 10x is equal to 60. Divided by 10 on both sides, and so x must be equal to 6. Again, I cannot say this enough. Please make sure you're answering the questions. I'm going to go back and make sure I'm finished. It says find x and pm. So I'm not done. X is 6. I've got to find pm. So here's pm. I'm going to plug that 6 in for my x. 5 times 6 is 30 plus 8, 38. So PM is 38. Okay, I think you have enough information there. I do think I am going to skip example 6. I think with example 5, you should be able to figure that one out. If not, don't hesitate to ask a question. All right, catch you later.